Okay. All right, now before we move on, just sound check on your side. You can hear me clearly, Nizam and Edmund?
Yeah, I can, sir.
Okay, all right. Let me check my pointer. Okay, good. All right. Now, previously, if you look at the top of the title there, so we already explained what is sequence. All right. So Edmund, make sure you understand what is sequence. Today we're going to focus on more on the series. We already done sequence. Sequence means number, individual number, 1, 2, 3, 4, 5 until a certain number. Series is a addition, means you add all the number together. We call them this action, add all these number together. We call it series. Okay. So today we're going to look at series. So according to Zeno paradox, where every time you move, you are half of your previous distance, right? So for example, the door until the end of the corridor there is 1 meter. And the first time you move half of the distance. Second time it become 1/4. Third time it become 1/8 and so on. So if we define the Zeno paradox using series, then this man, we can say that it can reach the door after a multiple trial to reach the door. Okay, so what actually series? So this is series. This is a pattern of series when we write series. So we know that at the far end there you see number 1. Number 1 means the total number. The total number in this case from the door until the end of the corridor or the starting point is 1. And then this 1/2, 1/4, 1/8, 1/16, 1/32, and so on. You see that this set of number is 1/2 power n. So if you add all these number together, big enough, you will get the number 1 there. So this is how you write series. Okay. And mathematically, there's a way you write series. So again, reminder, this is how you write sequence. This is how you write sequence. You use curly bracket, an, and then you start with n equal what? So in this example, you start with number 1, n equal 1, until infinity. So this one is infinity or infinite sequence. So this is how you write sequence. Today, we remind you that we are learning about series, no longer sequence, but we will use the concept of sequence, go into series. So what I mean by series? Series means the lump sum of the sequence, the lump sum of all the numbers together. We call it series. So if you add all the numbers, for example, A1 means number 1, number 1, A1 plus A2, A3 until the last one. And again, you see 3 dot there means it is an infinity number. So in this case, if you see the 3 dot, like what we learned in sequence, if you see 3 dot, it means infinity or infinite series, because you see all the plus here means you just add in the wording of series. So, or in the future, when we mention series, it means infinite series. Okay. So this is how we write series. So this blue color, or we use the sum symbol, and this is your sequence. This is your sequence an. On the left hand side, you'll see this is n equal to 1, means you count from number 1 number until infinity. Or sometimes we don't have the limit, we just use a general symbol like this, and then we add all the sequence together, will become series. Okay, so before we go into deeper, make sure you understand what is sequence, what is series. So I did give you 2 symbols here. On the top, this one is sequence. The blue color, the sky blue color or light blue color, these 2 is series. You see this is a sum, symbol of sum. You add together all the number, we call it series. So remember, this is a way you communicate in exam. This is a way you communicate in the test 1 and test 2 and final exam. So if you want to tell me that you're answering for series, use this symbol. If you are mentioning that you're solving question for sequence, you use this presentation. Okay. All right. Now again, this is a reminder. Sequence in this pattern. Okay. Sequence in this pattern. Series in this pattern. So try to identify how you write series, how you write sequence. And if you see that you need to add first number, second number, third number, and until infinity, this type of mathematics procedure, we call it series. Okay, so just a check question. Ask yourself, are you able to identify which one is series, which one is sequence? If yes, then we move on. Okay. Stop me if you're not able to understand what I'm talking about. All right, especially the information behind my back here or at the screen here. Okay. So the next question on the screen here. Does it make sense to talk about the sum of infinite numbers? Does it make sense? So this one also we covered in the previous lecture. If you want to add all the numbers until infinity, it doesn't make sense. You can only know that the final answer will be infinity. Okay, you add the number large enough and you continue to add with the 3 dot there. It means you continue counting, so you will never reach one number. You will continue, the number going to be bigger and bigger. So this one fall under infinite series. Okay. So there's a way to communicate with a mathematician. Okay. So you know that Zeno paradox is a pattern of number. In this case, in the pattern of 1 over 2 power n. And you know that the total distance from the door until the end of the corridor there is 1. So the blue color there, the sum of this series or this series, you know that is 1. Okay, so 1 represents the adding of all these numbers. Okay. So I already explained in sequence series, for example, if you mention about series, don't confuse with the sequence. We are now in series. So in series, actually, we are more concerned of the number added together. For example, can I go further? So for example, how when the n is 1 means you add the first number together, you will get 0.5 if you look at the Zeno paradox data. In this table, if n equal 2, is n number 2, it is not number 2. But when you come to series section or series chapter, when your n is 2, it means you add 2 numbers together. In this case, you add 1 over 2 plus 1 over 4, the first number and the second number together. That's why you write n2, and you add 0.5, you add 1 over 2 plus 1 over 4, you will get 0.75. Edmund, do you know how to get 0.75 in this table?
1 over 2 plus 1 over 4.
Correct. So because we are talking about series, we talk about series means we add 2 numbers together. In this case, we add from the first number and the second number. And then let's see if you're able to understand how you get n equal 3. N equal 3 means you add the 1 over 2 plus 1 over 4 plus 1 over 8. You add them together, you get 0.875. And as you add more number together, from 1 until, let's say, 25 number, from the first number until number 25, you will see that the pattern of number here, it will very, very near to 1. Okay, so this is a series for 1 over 2, you will get near to 1. How you write this? Series in mathematic form? This is the way you communicate with the mathematician. You write the far blue, you see the 1 over n with the epsilon symbol here, as you can see here. We communicate this set of series in this very simple formula. You use a sum information, you use a sum symbol. 1 over 2 power n is represent the sequence or the pattern of the number. You'll get equal 1. Try to compare this table and this formula. If you don't understand, ask me now. You cannot relate this set of number to this pattern or to the way you write sequence. The way you write series for 1 over 2n data. Nizam, you able to relate this one and this one?
Yeah, I can do.
Okay, good, huh? Okay, let me check the attendance again. Okay, Shakil, Saman, you there, right?
Yes, sir.
Yes, sir.
Okay, good. Shakil, you able to relate this table and this series presentation?
No, sir. Can you repeat?
Okay. Now, we are now in the series chapter. So series means it's a sum of number. It means series. So you have to differentiate between series and sequence. So if you don't understand what is sequence, listen back to the previous video. But series is an add of all these numbers together. Or is you add all the sequence together, you get series. Okay. Now, if you look at this table, what mean by the n for series condition? N means you add one number. You add the first number. So what is the first number in the Zeno paradox phenomena? Sakir, what is the first number in the Zeno paradox number? Shakir, you able to hear me? Shakir, are you there?
Yes, sir. Yes, sir.
Shakir, are you there?
Yes, sir. Yes, sir.
So, yeah. So, what do you understand about n? What is n? What is n? Nizam, can you explain to Shakir what is n in this table? What mean by n in this table when it comes to series data, series chapter? When you talk about series, what is n?
N is the numbers of the 1 to 3. The one related to half. Half is the first number, and then quarter is second number. 1 over 8 is third number, something like that. So
Okay.
1 to 3 is, if 1 means only the first sum,
Yes,
if 2 means
correct.
together with 1 and 2. 3 means
Correct.
1, 2, 3. 4 means 1, 2, 3, 4. So all
Correct.
together.
Good explanation. Shakir, you understand what mean by what explained by Nizam just now?
Yes, sir. No?
Shakir, you understand, right? You understand? You understand? Okay, we are having a quiz, so if everyone understand, we are going to have quiz, so but not now lah. But I'm going to ask question. If
This
everyone
chapter,
understand,
sir,
I'm going. Sorry, again.
is on this chapter, right?
Quiz can be anything that I just taught 5 minutes ago.
Oh, okay, all right.
So if you don't understand, stop me and ask me question. So the hints I give you to you when it comes to quiz is that I will ask everyone, do you understand? So if all you understand, I will have quiz in that particular time. So there's no reason when you answer, you understand already, then I give you quiz, so you should able to complete the quiz in 5 minutes. Okay? So when you come to series again, so those watching on YouTube, if you already understand this table, you can fast forward to the next slides. Okay? Yeah. So back to the class. So yeah, for those in the class, just for your info, this video is recorded and shared on the YouTube. Okay. Yeah. So if you talk about series means the adding of the numbers. Series mean adding of the number. Sequence mean individual number. So make sure you understand what I mean by series. So if you look at this table, when you talk about series, okay, when you talk about series, the n, it means you add the first number. So if you look at Zenock paradox data, the first number is what? 1/2. So n1, you only add 1/2. What you get? You get 0.5. And what happens if you increase the n? What happens when the n is 2? What is the data for Zenock paradox data? If n equal 2, when you talk about series, it means you add two numbers together. You means you add the first number and second number. What is the first number in Zenock paradox data? 1/2 plus 1/4, you get 0.75. You repeat the same concept. What happens if you talk about series and the n is 3, and we are using Zenock paradox sequence in a pattern of 1/2n? So you add the 3 number in front of this sequence. So how you get 0.75? When the n is 3, you take 1/2 plus 1/4 plus 1/8, you get 0.75. Saman, you understand?
Yes, sir.
So as you increase the n, means you add more and more number from the first number. Let's say 10. What I mean by n equal to 10 in series chapter? It means if your n is 10, means you start adding the first number until the number 10 data, you will get 0.999 something, and you continue to add until 25th number. You're going to add very, very near to 1. Okay, so this table or this set of series, you can write in a very simple equation, which is this one. You know that the set of data or sequence is in the pattern of 1/2n. For Zenock paradox condition, you can write 1/2n, and then you use, if you communicate with us that you're meaning series, then you use the sum symbol. You start from n equal 1, you start from number 1 until infinity, you're going to get 1. That's why from this table, you can write in this equation, equal 1. All right. So I pull the thing back. So in another way, you can write, or in the future, we can use the series presentation. For example, the first set of number, or in this table, n equal 1, this one, n is 1, you get 0.5. How you represent this first set of series? In mathematics, you write S1, series 1 means n equal 1, series 1 equal to A1, means you add the first number. What happened? N equal to 2, and how you represent the series? Series S2 means n equal to 2. It means you add the first number and the second number. A1 means first data or first number. A2 means second number, and so on. So if you look at this pattern, you can write in the general mathematics equation. You can write Sn, because by comparing these two concepts, you can write Sn. N means the number, equal to A1 plus A2 plus so many until the last number, An. So do you understand how you develop this equation? Nizam, you all right? You understand what is the meaning of S? What is the meaning of A in this equation?
Yeah,
Okay,
S
good.
is sum, right?
Yes, S is sum. Sub n means the number of the total number you want to add together. Sn equal, and then you start writing. A1 means always the first number, second number. A2 means second number, plus until you get to the last number. This equation is for series. This equation also equal to this blue color equation. This one, of course, this one, you see that we are substituting the an equal to 1 over 2n there. Okay. This morning, I want you to recognize the way you write series. So you can either write this one, if you're very hardworking, you can write Sn equal to A1 plus A2 plus 3 dot means you continue to count, plus An means the last number. If you're hardworking, you can write this one in the exam, but as you do more and more exercise, you will find this one very troublesome. You, at the end of this module, you'll prefer to write in this way. Okay, how you communicate with the reader that you mean series, straight away you use this kind of form. You write Sn means you are talking about series, equal sum of number from what number you want. Okay, and ai, or you can represent, you can change this I to n also can. Okay, n equal 1 until n equal n also can. Okay, so this is a general equation. This one equal to this one, same thing. Huh? This equation is the same thing with this one. All right, so remember, I circle it for you. This is the way you define series. This one, huh? This is the way you represent series. Okay, this is the way you write it. Now, what happens if you add a limitation to our partial sum or sum of our number? What happens if you have a limitation of your series? Okay, so if you count your n until infinity, if you write in this way, okay, if you have a limit n to infinity, if you change the number of, if you have limitation n equal to infinity, what does it mean? It means you count from number 1 until infinity, you will get infinity number, means the sum of infinite series, or you can use this symbol. Okay, so this is the way you communicate what happened to your data. Okay, so this one is a general series equation, and once you add the limitation or the number of count in your calculation, series, if your n equal to infinity, you will get infinity number. Okay, so just take note on this one. This is how you write in mathematic form. Okay, so again, recall what is converge, what is diverge. So if you are not sure what is converge, diverge, go and watch the sequence video. We already covered quite a lot of time, and Nizam already become expert of convergent and divergent. Okay, so you can ask your classmate Nizam to explain to you what is convergent and divergent, okay? All right. Now, if your series is converged, means when you add all these number, you get one finite number or one number. For example, this CNOT paradox series, you add the steps done by this person, you add all the numbers together, you'll get 1, because you know that the total number, the total length from the door until the corridor is 1. So this set of data, we call it convergent. So when it's convergent, then you write in this form. Okay, you write S equal sum symbol, I equal 1 to infinity A1. S means there's a number there. Okay, S means there's a number there. So this is the way you define your series if your series is convergent. Okay, so this is how you write your convergent series. This is how you write, huh? Okay, so the one that I highlight with the box, make sure you understand what does it mean. And most of the time you'll use this equation in your exam or test, or even your assignment. Okay, make sure you understand. Let's look at example. Okay. We see 1 or 2 example, then we go for a short break. Now, if you look at example number 11, the question asks you to find the sum of this series, okay, this series, if the sum of the first n term as follows. So you are given the Sn equation, okay, the series equation. So Sn equal to A1 plus A2 plus 3 dot means you continue to count, plus until the last number. The equation of the series is 2n divided by 3n plus 5. How you find this set of series? And if you look at the question, what is the limit? You start counting from n equal 1, means you start counting the first number until infinity number. What does this number will be? Does it convergent or divergent? So this is the steps. First, look at the question. Identify the formula of the series. In this case, your series is 2n divided by 3n plus 5. How do you find A1? How do you find A1? If you want to develop this series, let's see whether you can guess what is A1. A1, n equal 1, what do you get? Someone, you want to try? What is A1? If your formula is this one. What is your A1?
2 over 8.
2 over 8, correct. Edmund, you understand why the first number A1 is 2 over 8?
No, sir.
Okay. Edmund, A sub 1, A1, what is your n number?
1 over 2.
Now you look at A sub 1. A sub 1. You know what do I mean? I mean this one. You can see my mouse. I mean this one. A sub 1. What does the n mean? What is your n? N equal what?
1.
1. So what do you get if your n equal 1? Edmund? What do you get if your n equal 1?
2 over 8.
2 over 8. Now you get it, right?
Yes.
Okay, just try if you're able to capture. Edmund, what is your A2? If you're according to this formula, what is the A2? Shakil, standby answer if Edmund not able to answer. if your n equal to what number you get? Edmund, what do you get on the first, on the top, this one? If n equal to?
4.
What do you get if n equal to at the bottom?
11.
Okay, so total is what you get? 4 divided
11.
by 11. So this is how you count. The first number, you substitute n1 plus n2 plus n equal 3 and so on until the last number. However, the question asks you to calculate until infinity. Do you see the symbol? Sum n equal 1 until infinity. So you need to add this set of number until infinity. So what do you get? Let me move my mouse away. So the first steps, you solve series question. You write the general equation. You see the red color? I write the sum of an. Below there, you see n equal 1 until infinity. This is you copy from the question. You copy from the top, this one. You write it on your answer sheet there. Equal, how you write? You start using limitation to help you to solve this kind of question. Okay? So today what you learn, you want to solve series question, you start using limitation. So you start limitation n to infinity Sn, you write, So the first step, you copy the question. Second step, you are using limitation, you write limit your n to infinity, means you count until n to infinity, means the infinity number. Sn means the series. Then you continue to substitute what is your Sn. You like limit n to infinity, you substitute your Sn in the equation, right? This one, Sn to the blue color, 2n divided by 3n plus 5. Okay, so this is your first step, solving series problem.
Can I explain again?
Which part? This one or this one?
The substituting the Sn.
Okay, you don't understand. You don't understand the red color and the blue color.
Oh, okay, so I understand.
It's just a direct substitution. Sn with the blue color. You see, the question already tell you what is Sn already. Sn equal to this presentation or this formula. There are two ways to tell the series, either this one or this one. So you can write all this a1 plus a2 plus 3 dot plus an into here. You can use this one, but I prefer to use the formula because this one you cannot see the pattern. You can only see the data, but this one you can see the pattern of the sequence or pattern of the series if you want.
Right,
okay. Now after you get this one, the rest you need to eliminate the n. You need to eliminate the n. This one was same as what we covered in the previous example. So you look at here. You look at the bottom, the denominator. You look at the n. What is the maximum power of n? Shakir? What is the maximum power of n for the denominator? Shakir, are you there? Shakir, one time. Shakir, second time. Shakir, are you there? Shakir, third time. Okay, consider Shakir lost connection at the moment. Nizam, you want to try? What is the maximum power of n in the denominator? What do you see? What is the maximum power?
Maximum power 1.
1. So maximum power 1, you can write n power 1 and then use this n power 1 to divide this one, and this one. Okay, first step, you write the equation. Second step, you look for the denominator, the maximum power of n. You write the maximum power of n in this form, n power 1. The next step is that you divide the whole equation. The top one, you divide it by n. This one, you divide it by n. This one, divided by n. Or you can put the whole thing this one, the whole thing, 3n divided by 5 divided by n. Okay, so you will get from this form to this form after these steps. So after this step, after you find the maximum number of n or maximum power of n, 2n divided by n, 3n divided by n, 5 divided by n. So actually this one, 3n divided by n, you can write in this way. Huh? Any question from here to here? Anyone want to ask me a question? You don't understand why suddenly this one can become this one?
Yeah, first we have to find the highest denominator for n, right?
Correct.
Okay, which is 1. And
Not
then
1.
when we
The highest number of 1 is 1. So what is the final product of n power 1? What do you get? N power 1 is what?
n.
N. So continue explaining. And then after you get n, then what do you do with the n? The next step is what?
We
divide.
right?
You divide everything in the equation with this one. So you take 2n divided by n, you get this one. Then the whole thing the denominator, the whole thing denominator is 3n plus 5. You divided by n, so you can write either 3n divided by n plus 5 divided by n, correct? You understand how to get from here to here?
Yes, I understand.
Okay.
So, but the denominator is always 1, right, sir?
Not necessary. This tutorial question is 1. So if this one is 2, okay, if this one is 2, n2, then the whole thing you need to divide it by n2. Mean this one n2 divided by n2. This example, because 3n power 1, your n is 1, so you are dividing with n. Okay, and most of the time for this module, your n will be less than 1. Just for your info, just give you some tips. For final exam, your n will not be 1, it will be less than 1 or -1, -2 or something. Okay, yeah. So we continue with this example. Once you find your n, you divide the top and bottom with n, you get this form. Then you rearrange this equation. 2n divided by n, you get 2. 3n divided by n, you get 3 plus 5 plus n. So the next you'll get 2 divided by 3 plus 5 divided by n. Remember to carry the limit in your answer. So here to here to here. So when I mark your answer, this one will carry 1 mark, this one 1 mark, this one to this one. When I see this one, your steps, I'll give you 1 mark for understanding. You know how to find the highest power of n when you write this one. So I'll give you 1 mark for this one. So 1 mark, 1 mark, and this one 1 mark. Then you need to find the answer. So how to find the answer? Our objective why we divide with n is because we want to eliminate the n on the top. This one. We want to eliminate the 2n become 2. And then the denominator, the whole equation only have 1n. Do you see? We convert this one, top and bottom with n. We reduce to only 1n. This is our objective. This is our goal. Our target is to change the equation with 2n. We reduce it to only 1n. Why? Because we need to use the limitation operation to help us to calculate the number. Okay, so we continue from here. What happens if you increase the n to infinity? What happens to 1 over infinity? Or you can take this 1 over n divided by 10. 5 divided by 10, you get 0.5. You increase the n a bigger number, you increase by 1,000. 5 divided by 1,000, you get 0.005. And you keep increasing the n. you keep increasing the n to infinity, what do you get?
0.
Nizam, what do you get?
Be 0.
0. So if you use limitation, you limit the n become infinity. 5 divided by infinity, you get 0. So straight away, you can answer this question. The answer is 2/3. Okay, so this is an example how you solve sum of series question. Yeah.
So when we want to know if it's divergent or convergent, right?
Yeah.
We ignore the 2 and 3, is it? We just look at the 5/n.
No. Convergent, divergent, actually look at the final answer. This is the final answer, right?
Okay.
If you add all the number, you get one number, right? I mean, this set of number, this set of pattern.
Oh, okay, okay.
Yeah. You add all the number together until infinity, you will get 2/3. So you get one number, this means this set of series is convergent. Means you are near to 2/3 if you add all the number together. Until infinity, you will get near to 2/3. The previous Zenock paradox is 1. So in this example, 2n divided by 3n plus 5, you add this number, this set of number until infinity, you will get to a total number near to 2/3. So this example 11 is convergence series. This series is convergent. Okay, let's see. Next one. Oh, I forget to hide the third one, so ignore this one. Look at the question of example 12. Show that this series is convergent, then find the sum. You need to show whether it's convergent or not convergent. Again, convergent means that if you add all these numbers together, you'll get one number, one solid number. And you see this question give you to count from the first number until infinity. Okay, you look at the sum symbol there, n equal 1 until infinity, the top and bottom. The top is infinity, but the bottom one, it tells you to count from number 1. So if you really don't understand, you can develop this equation. You get the first number, you get the second number, you get the third number, and then you start to add the number together. But it will take quite a long of time. Okay, so just tell you that this sequence the pattern of the number is 1/n divided by n plus 1. So just recap or just to recall the technique that I just teach you just now. Apply to this question. Standard, we call it standard, means same procedure. If you can answer, if you can understand example 11, you can do example 12 using the same method. So what is the first step? First step, again, you copy, you write what is your Sn. You copy the question, you write what is your Sn. So your Sn equal to the sum of n equal 1 until infinity, and the pattern of that data is 1/n plus 1. You write this one, you get 1 mark. What does it mean? It means if your first set of data, if your n equal 1, what is this equation will tell you? If your n equal to 1, you get 1 divided by 1 times 2, right? If your n equal 1. Anyone, you don't understand why suddenly you seeing 1 divided by 1.2?
Yeah, also.
This one, you replace n equal 1, means you count from the first number. You change this formula to first number, the number that you can see. This is formula, right? Then you replace, you substitute n equal to 1, means you find the first number. What is the first number? What is the first data if you use this equation? 1/n times n plus 1. When you n equal to 1, the top one you get 1. Then this n become 1. N become 1. How you get 2? The bracket n plus 1, your n is 1, you get 2, right? Anyone still have question how you get this one? Do you understand how you transform this one to this one? This is your first number or first data. But you look at the question. The question asks you to continue to count until infinity. You need to expand this equation, this series equation into the numbers. So the first number is 1 divided by 1 times 2. Dot means time. Can you guess the second number? Plus. Okay. Plus. I give you hints. So I give you the answer. What happened to n equal 2? 1 divided by n become 2, you get 2. N become 2, 2 plus 1, you get 3. This is the second set of data when your n equal 2. But again, we are talking about series, this series name. Series means you add the number together. So this is n A1 plus A2, and then you continue. Just to test the class. Shakil, can you guess the third number? What is the third number by using this equation?
1/3 times
Times what?
4.
Correct. This is the third set number. But why there's a plus there? Because we are in the series chapter. We talk about series. So there's a plus there. If it's a sequence, you replace the plus by comma. Okay, if it's a sequence, if you look at the data, individual data, and it's sequence, then you get a comma. Comma, comma. But when you talk about series, it means you add all the number together. You need to use the plus symbol. Okay, Edmund, what is the fourth number? Can you guess what is the fourth number, Edmund?
1 over
what?
4
4. This one?
times 5.
5. So 4 times 5. This is the fourth number. Until infinity. Okay, until infinity. Until the last number give you this pattern. 1 over n times n plus 1. So 1 mark for the equation. Then you need to expand this series in this pattern. This will give you second mark. Any one of you don't understand how to convert this equation to this pattern. First step, you copy the question. Second step, you expand. What is the series mean? Means you expand it into numbers. First number plus second number plus third number until the last number. So the last number is this formula. So you just copy plus the last number 1 over n times n plus 1. Once you get this one, this is 2 marks question. 2 marks. First, you write the equation, you get 1 mark, and you expand it, you get another marks. So 2 marks here already.
So how many times do we have to expand it before we put the infinity sign and then the formula there?
My advice is 3. You do 3 number. You hardworking, you do 4 and 5 lah. You hardworking lah. But it's sufficient to do only 3, and then you give the formula for the last number. Okay. You write number 4, number 5 also same mark. You also get the 1 mark for expansion. So no matter how many you write, also 1 mark. So minimum 3 number in front. Okay, now the purpose we write this one is to see the pattern of the series or the pattern of the data, so that you can make conclusion later on. Okay, we will, this one we will, if you do not know what is a partial fraction decomposition, we will cover when we go into integration later on, or you already cover in your maths one. Okay. So don't worry, we'll come back to this one. We can use the same idea. So what does this partial fraction decomposition means to you if you have this kind of data? 1 over n divided by n. What you can do is that you can write 1 over I times 1 over I you can write like this. I'm trying to modify this equation to this form. Okay. So basically, if I add the blue color, it doesn't change to 1 over I times I plus 1, right? I just add one blue color number there because I want to modify this equation. Okay. Then once I add these two imagining number, because plus I minus I, you cancel each other, but you add them in because you want to build the equation into this form. So you can expand this equation into two terms here. The front term is 1 plus I divided by I times I plus 1. And then the second one, minus I, you can split into another form there. Okay, the form there. Okay, I think this one is plus, not the negative. So this one is plus, typo error. So by having this one, you can cancel the top and bottom. This one. You can cancel, factor out this one. You can cancel the top and this one. Then you can cancel the I for the second one. So you will reach these steps. Okay, you'll get 1 over I minus 1 over I plus 1. Okay. So, okay, let me check now. Something looks very weird here. Yeah, okay. There's a typo error in my slides. Okay, there's a typo error in my slides. So this should not have negative sign here because we already have negative sign in front. So there's no negative sign here. So just take note there's a typo error in my slides. So you cancel, you get this one. So we transform this one into this one. Okay. Anyone have question on this equation? Anyone don't understand why suddenly 1 over I times n plus 1 you can reach this one? Anyone you don't understand? Or you need me to explain one more time?
One more time, sir.
One more time, sir.
Okay, so basically what we do with 1 over 1 times I times I plus 1, right? So we do a little bit of magic on this mathematic here. What we do is that we add number in the equation. Basically, we add in the blue color equation. Do you see plus I minus I? Do you see it, Shakil or Edmund? Do you see it, this one?
Yes, sir.
Yes, sir.
So you know that what happened if you're plus I minus I? What do you get? What do you get? Plus I minus I, what do you get? So there's nothing, right? So it just actually you add something in the air. Because you want to transform this equation. We just add something in the air. There's nothing there actually. We just add something blue color there. The left side and the right side actually the same. We just add one more magic there. Understand? We do not change the equation on the left. Understand? Everyone get it?
Yeah.
Then the next one is just to expand the equation. You just expand this one. You just break into two equations. 1 plus I divided by the same denominator. And again, there's a typo error here. This should be no negative here. It's a negative I divided by I plus 1. There's a typo error here. So we just expand this one to these two. Typo error, there's no negative here. Okay, negative already bring in front of this one. Okay, this one become here. So there's no negative already. Huh? Clear? This one clear? Then the next step is just cancelling the term. You are seeing this one, right? 1 plus I, 1 plus I. 1 plus I, 1 plus I, you can cancel. What is I and I? You can cancel, right? Cancel, right? I cancel with the arrow. Then you get this one. The first one, after you cancel, you get 1. Divided by I, you get the first one. Minus, you continue to carry. You cancel, but there's a 1 there. So 1 divided by, you already cancel out the I, you left out I plus 1. You get this one. Everyone clear? How to get from here to here? Any question? Or is still unclear? Why suddenly this one become this one? Let me know, if you're not clear.
Yes, sir.
Okay. Now we can write. Do you see the pattern of the equation on the left and this one? Do you see the same thing? We just the difference is just n, and that side is just I. Actually, it's the same thing. So we can write this one, the sum of I 1 divided by I minus 1 divided by I plus 1. Okay, you can write Sn of Sn means this number, this set of series. You add all the number together with this formula. So you can write Sn equal to this one equal to this one. Basically, you derive the equation just now already. Okay, you write this equation. Sn equal to sum of this one equal to this one. Basically, you transfer what you learned just now into this equation. But this set is actually, when you have the sum sign, it means it's a Sn. So you transfer the data. So we're able to write Sn equal to sum from I equal 1 until n, 1 over I times I plus 1. So again, you do the calculation again. You calculate what is the first number. You replace your I equal 1 or n equal 1. The first number you get 1 over 1 times 2. Your n is 1. Now n is 1, so 1 plus 1 you get 2. You get the first number. And again, you are talking about series again. Series means you add all the number together. So back to the question asked by your friend just now, how many number we need to write? You write 3 number. So I write 3 number. This is the second number. When you replace n equal to 2, you write in this way. When n equal to 3, you get this one. And then you copy the formula. So the next question is that, do you see the pattern of an and Sn? An means this individual number. So you can write, this is the normal, this is the formula, the general formula for series. Sn equal to A1 plus A2 plus until the last one. This is a formula that we see just now. So if you plot the numbers, right? Blue color. The blue color is the data, individual data. The blue color is the individual data, or we call it sequence. We learned in sequence chapter. sequence, individual data. The first, how you get this dot when your n is equal to 1. 1 divided by 1 times 2 is half. So is at the center of the y, this one. So when your n equal to 1, you plot 0.5 here. Then what happened? What is the next number? 1 over 6. 1 over 6 is about here. And then the third number, fourth number. And as you can see this pattern, right? As you can see this pattern. What is this pattern? If the blue color is a sequence, the blue color is a sequence, does the sequence converge or diverge? Nizam, the blue color is sequence. Does the sequence converge?
Yeah.
Yes. This is individual number when we talk about AN. What happens if you add all the number together? You see the red dot? If you add the first number, you get this one. If you get the second two number, you get this number. Means you add this one plus this one, you get this dot. Third number, you add 1, 2, 3, you get a third dot, and so on. What do you see? What is the series pattern? Does it converge or diverge? Nizam?
Still converge.
Still converge, right? If you continue to add in your n, will the n stop at one number? Yes or no? It seems like the number will stop at one number, right?
Yeah.
Yeah. So yeah, this pattern can tell you, yeah, it is converged. I agree with you at this moment. Yeah, the number is getting flat. So let's do mathematically. We transform the equation left to right. Left to right. What happens if you increase the n or increase the I to your I equal to 1? Okay, I equal to 1. So 1 divided by 1, you get 1. Minus 1 over, if your I is 1 or n equal to 1, you get 2. So 1 over 2, you get the first set. What about the second set? Second set is 1 over 2 minus 1 over 2 plus 1, you get 3. You do the third set. What happens if your n equal to 3 or I equal to 3? 1 over 3, you get this one. I equal to 3, 1 over 3 plus 1, you get 4, and so on. You get this kind of pattern, right? So 1 over n minus 1 over n plus 1. This is a pattern of the series that you get from the first three. You look at the first set, second set, third set, and then you can see the pattern of this formula. So if you add all these numbers together, look at the screen, I start cancelling number. If you add together, the first negative 1.2 plus 1.2, you can cancel, right? If you expand this equation, you add all the number together, half minus 1 over 2 plus 1 over 2, you can cancel, right? What happened to the 1 over 3? Negative 1 over 3, you plus 1 over 3, you can cancel, right? You can continue cancel. I label with the purple color arrow. And you continue cancelling the previous one and the back one. So you can cancel until the last one. What do you get from this set of data? What do you see? If we add all together, what is the equation you will get at the end? Do you agree we arrive at 1 plus minus 1 over n plus 1? Do you agree if we add this whole series together, we arrive at 1 minus 1 over n plus 1? Do you agree? Anyone you don't agree or anyone you don't understand? Why suddenly this one will become this one? Stop me if you're not able to understand why suddenly this set of data can arrive at this one. Stop me. I can explain one more time if you don't understand.
So can explain why you cancel off those ones?
Okay. You understand what is series? Is it Edmund? Edmund,
Yeah.
you're the one who asked, right? You understand what is series, right?
Yes, sir.
Edmund?
Yes, sir.
Hey, just now, is it Edmund asked me question or
No, it's not me.
who? Who is the one who asked me to explain one time?
Sir, it was me, sir. Sorry.
So what is your name? Because I cannot see who is asking. Saman, is it? Saman or Sakil?
Yes, sir. Yeah.
Saman or Sakil?
Saman.
Okay, Saman, you are asking. You understand series, right? You have the
Yes, sir.
equation here. So how you get series? How you calculate series? You get the first set, then you get the second set, then you get the third set number, right? You get the first number. So how you get the first number? You replace n equal to 1, right? In this formula. So n equal to 1, what do you get? 1 minus 1, 1 divided by 1, and then minus 1 over 2. You get the first number. You understand the first number? The first bracket? Saman? You understand how you get
Yes,
the
sir,
first
yeah.
bracket? Then the second bracket, n equal 2,
Yep.
or I equal 2, then the third set. If you remove all the bracket, because you want to add all the number together, right? Series is you add all the number together, right? You remove all the bracket, you ignore all the bracket, all this bracket. How do you calculate minus 1 over 2 plus 1 over 2? How do you calculate it? You cancel, right?
Yeah.
So you cancel the first one. Now you ignore all the bracket because you already want to calculate all the number together. Now what happened to this one? Minus 1 over 3 plus 1 over 3. What do you get? You can cancel also, right?
Yeah, can.
You repeat this kind of pattern until the last one. You can cancel 1 over 4 to the next one, 1 over 4 also. And then the last one before this one, you get negative 1 over n, right? Because it's always same as the previous one, only the plus and minus sign. Do you see the logic? Saman, do you see the logic? Why we can cancel 1
Yes.
over 4 until the last one, this one?
How did you cancel 1 over n?
Do you see the pattern? Do you see the pattern of the green, blue, the light blue and the purple blue?
Okay. Yeah. All right.
We can always cancel the previous one because the number always repeating.
Yeah.
Right? So if we see the same pattern, so the previous one, the previous number before this will be negative 1 over n, correct?
Yeah.
Negative 1 over n plus 1 over n. You can cancel. You repeat the same number, same pattern. So you arrive at 1 minus 1 over n plus 1. Saman, do you clear now? Why suddenly you can write this one to this one? Okay. All right. So the next step is just to put in the limitation. Because you want to solve series, you always need the help of limitation. So you put the limitation n to infinity because the question asks you to calculate from 1 until infinity. So you put in the limit n infinity Sn equal limit, and then you substitute what is your Sn. Your Sn is 1 minus 1 over n plus 1. You just substitute what is your Sn. Then tell yourself, you look at this equation. What happened if your n is infinity? What happened to this number? Saman, what happened to this number? If your n is infinity, what happened to this number?
If your n is infinity.
A very, very big number. You 1 divided by very big number plus 1. What do you get?
Oh, it's gonna be 0.
0. So this one 0. If you n near to infinity, this one 0. So the answer is 1. So if you add all the number and you get 1, it just means that this set of series is convergent. If you're able to get one number, means it's a convergent. Okay, 1 plus 0, you get 1. So this means this is convergent. And the sum is 1. The sum is 1. And you're able to get 1, it means it's convergent. If you get infinity, it means divergent, means the number keep increasing. Okay. Another method is the O method, or I call it a very hardworking method, means you use graph to help you. So this one, if you increase, you'll get 1. Infinity, if you go to infinity, it will very, very near to 1. You're near to 1. Okay. So this is how we solve this kind of question. Example 12. So we solve this question. And this is how you write the final answer. You copy the question, the sum of 1 to infinity, the equation in the question equal 1. You get the full mark of 2 marks for this one. Once you do the steps, you rewrite the equation. You write equal to the final answer you calculate just now, equal 1. You get full 2 marks here. Okay, or you can support with the graph. If you are hardworking, you can plot with the graph. Okay, we stop the recording here. You'll go for a short break. Okay, let me stop the recording.